This is acceleration analysis. The rate of change of velocity with respect to the time taken time is known as acceleration, and it acts in the direction of the change in velocity. Acceleration is of two types, tangential accelerations and radial or centripetal acceleration. The rate of change of velocity in the tangential direction of the motion is known as tangential acceleration, at is equal to dv by dt, whereas the rate of change of velocity towards the center of rotation is centripetal or radial acceleration, ac v square by r. The tangential component of acceleration occurs due to angular acceleration of the link. The acceleration of intermediate points on the link can be obtained by dividing the acceleration vector in the same ratio as the points divides the link. Coriolis acceleration components. Consider slider moving along a rotating link, omega angular velocity of the link, alpha angular acceleration of the link, v linear velocity of the slider relative to the link, f linear acceleration of the slider on the link, r radial distance point p on the slider, acceleration of p along a r, acceleration of slider minus centrifugal accelerations, acceleration AAR is equal to F minus omega square R. Acceleration of P perpendicular to air Coriolis component plus tangential acceleration. A perpendicular is equal to 2 omega V plus R alpha. Coriolis component acceleration key points. The components 2 omega V is known as Coriolis acceleration components. The Coriolis components positive if the link rotates clockwise and slider moves radially outward, or if the link rotates counterclockwise and the slider moves radially inward. Otherwise, Coriolis component is negative. The direction of the Coriolis acceleration component is obtained by rotating the radial velocity vector b through 90 degree in the direction of the rotation of the link. Planes constructions. In planes construction, the velocity and acceleration diagram are superposed directly onto the configuration diagram itself. The line represents the crank in the configuration diagram, also unique map to represent both the velocity and acceleration profile of its moving ends. Acceleration images are highly useful to determine the individual acceleration of the offset points on mechanical links. The acceleration image of a link is constructed in the identical geometric manner as velocity image. The relative coincident acceleration, the acceleration of a point on a link relative to a coincident point on a moving calculated as vector sum of the absolute acceleration of the link, acceleration of the coincident point, the acceleration of the point related to the coincident point, and the corresponding Coriolis acceleration components.